So when we say resistivity, it is often referred to as specific resistance. The reason it is called as specific resistance because it depends on material. So it is material specific. For example, if it is copper, then it will be having a fixed value for copper. If it is gold, likewise, for all metals, it will be having specific values. Okay, so resistivity symbolically is denoted by rho, and it is just a part of formula for resistance. Okay, now when I talk about resistance, so resistance mathematically for any wire which is of cylindrical shape, having length L and area of cross section A, has this relation, like R is directly proportional to L and R is inversely proportional to area. When we combine them, so we remove the proportionality, so we can say that R is equal to rho L over A, where L is the length of the conducting wire, A is the area of cross section, while rho is the resistivity. Okay, so this is how we use resistivity for resistance formula. Now this resistivity is material specific. So mostly in many questions when we have to just find resistance, this resistivity will be given. If not,
Okay.
then they will just ask us resistivity and they will give the resistance.
All right.
So this is the main formula which we have to ultimately remember. Okay, and from this I can just make different variety of questions. For example, if I just double the length of conductor, then how resistance will be affected? If I
Right.
make the wire thin, okay, let's say if I reduce the thickness of the wire, by half, okay, so by half means I am reducing area by 2, I can say that. Okay, so
Yeah.
if area is reduced by 2, then in that case the value of resistance will be affected accordingly. Okay, generally when thickness or thinness of a wire is connected, so it is connected more or less with radius. Okay, let's say they will say that if radius of the wire has become r by 2, so what will be the change in resistance? So if radius is r by 2, then how the resistance will change keeping the same length? We can see that in the formula of resistance we have r is equal to rho L by A. If length is same, radius is r by 2, then we can write area as pi r square by, or I should write first pi r by 2 whole square, and this will be pi r square by 4. Okay, and this pi r square by 4 I will put over here, and then I can get a new resistance value which will be r is equal to rho L over pi r square by 4. Now pi r square is originally area only. Okay, so if I will just rewrite this, I can write it down as 4 rho L over A. So the final conclusion is that the new resistance, which we can call it as R1, it will become 4 times the original one. So how the resistance will change with the change in radius, with the change in area, with the change in length, this is what we are going to solve using this formula. This formula is mainly applied for all those things. Okay, so this is all about resistivity and connected formula with this.